Well, I hope this works this time. Sorry about the wait, but as you'll see when I'm teaching you, technology is not my friend. But anyways, today we're going to do the second video. Now we're doing items in math that people tend to get wrong, and I have to cover pretty quick in class so I can get to the good stuff. So we're going to start laws of exponents. Laws of exponents. Now, when I was a kid, this was called the base, which it still is. That's what you're raising to the power of this. But now they tend to call this an exponent. So either way, you'll probably catch me calling it a power. But most people say the definition wrong. It's not the number of times you multiply. It's the number of bases you're going to multiply together. Now this is a minor thing, but this means I have 3 2's multiplied together, so it's a shortcut of multiplying. So instead of writing 2 times 2 times 2, I just say what's 2 cubed. Now notice I'm actually only multiplying 2 times though. Not multiplying 3 times. I have 3 2's that are multiplied together, so I have 2 multiplications. Now, I'm going to have you memorize 1 through 15 squared and 1 to 5 cubed. Now, if you want to memorize it over the summer, that's fine. So it'd be 1 squared is 1, 2 squared is 4, 3 squared is 9, all the way to 15. And then 1 through 5, the cubes of those. Now, here's the 2 trick problems most people get wrong. If I put minus 3 squared, and if I put negative 3 in parentheses and square it, is it the same answer? And hopefully you now would say no. I have no idea what I just said, but you would say no. The parentheses means that the negative is being squared also, so that means you have negative 3 times negative 3. And as we know, 2 negatives when you're multiplying makes a positive. But this is what's the opposite of 3 times 3. That's what a square means. So some people will say, hey, write a 0 in front of it. What's 0 minus 3 squared? Well, it'd be 0 minus 9, or negative 9. So if it's in parentheses, it's affected by the power. If it's not in parentheses, it's not affected by the power. Now, an even power, this is positive. An odd power, it's negative. Because if the power is 3, an odd number, that's 3 negatives, making a negative. A negative times a negative is positive times a negative. Now the first law of exponent is what's x to the m times x to the n. That's the first law. So if I say what's x squared, that really means x times x. If I say what's x cubed, that's x times x times x. So if I say what's x squared times x cubed, that means you would have 2 x's multiplied to 3 x's. That means you have 5 x's multiplied together. So I could do a bunch of these examples and then actually prove it, but the rule says when you multiply 2 things same base, you add the powers. Because you have 2, you have 3 more, that's adding the powers. So if I said, hey, what's x to the 7 times x to the 10th? Well, I could write out 7 x's. I could write out 10 more x's. That would be 17 x's. Or the rule, when you multiply 2 things same base, multiply, not add, but multiply 2 things same base, you add the powers. So if I said, whoops, what is x to the 20th times x to the 30th? You would say, well, that would be 20 x's multiplied to 30 more x's. So altogether, I have 50 x's. Woohoo! Now I can actually make this a little bit bigger problem. I could go 2x to the 7th times 3x to the 10th. Let's move this up. So, now these are called monomials. Mono meaning one, anomial meaning term. We'll talk about that some other time. But 2 times 3 is 6. X to the 7th times x to the 10th is x to the 17th. Woohoo! So we could actually make it better, bigger. X to the 7th, y to the 10th, times 6x to the 8th, y to the 14th. So you'd say, okay, no pluses or minuses. We're not adding or subtracting, so you just multiply. 3 times 6 is 18. X to the 7th times x to the 8th is x to the 15th. And y to the 10th times y to the 14th. When you multiply two things same base, you add the exponents. So doing this kind of quick, but I only have like 12 minutes. But anyways, let's pause. What does a bee use to help out his messy hair? He uses a honeycomb. Okay, sorry, that was bad. So let's see, 5xy to the 7th z, 3x to the 9th, y to the 8th, z to the 11th. So, okay, so 5 times 3, 15. X to the 9th, you got 9 of them, you got one more, so that'd be x to the 10th. Y to the 7th, y to the 8th is y to the 15th. And z times z to the 11th would be z to the 12th. Woohoo! That's one big monomial. Now, I have all these problems, 7 altogether. So stop the video, do these problems, then turn me back on and I'll do them, see if you got them right. Okay, good. I hope you got them right. Here we go. 2 times 3 is 6. X times x is x squared. You have 2 x's multiplied together. So x to the 6th, x to the 7th, x to the 8th, 7 8's 15. 6 more is x to the 21. Wow. Here we go. 3 times 5. I think that's a 5. Yep. 15 times 1 is 15. X to the 4th, x to the 7th, x to the 11th times x is x to the 12th. Now we will do this in class again. Probably, I think it's second semester. But for some reason, people have trouble with this. So I thought we'd review it. 2 times 3 is 6. X to the 3rd, x to the 4th is x to the 7th. And y to the 6th, y to the 10th is y to the 16th. Honeycomb, I just got it. That's pretty funny. Anyways, x to the 7th, x to the 6th is x to the 13th. Y to the 8th, y to the 10th is y to the 18th. Now, inside parentheses, so you square both things. Not in parentheses, so you're only squaring the 6. So if you got this right, good job. This and the undefined that I did in the first video are things that people just get wrong, get wrong, get wrong, get wrong. So hopefully you can remember that. But we will do this again in class. So this is the end of video 2. Honeycomb. That is funny. Ha ha ha. I'll see ya.